Now for adding and subtracting numbers with the same denominator, it should be pretty easy. If you have the same denominator, you're just adding them across. So you'll notice in step 1 it says multiply denominators to make them common. If they're already common, again, you're just adding across. So 4x plus 8x is 12x, plus 1 plus 9 is 10, and then the denominator shouldn't have changed, so it's 6x plus 5. And that's it. Pretty easy when the bases are the same. For adding subtracting with a different denominator, we multiply the denominators to make them common and then add across. So let's look at example 1. The denominator here is x plus 4. The denominator here is x plus 5. So we need to multiply to make the denominators the same. So I'm going to make a copy of this side. And this has x plus 4, but it's lacking in the x plus 5. So we're going to go ahead and write that out. So notice I'm changing the colors so you see where the difference is. So this is x plus 5 times x plus 5. Then we're keeping the addition. We're copying the entire side here. And we're multiplying by x plus 4. So when we multiply that across, or when we multiply that in, we are left with 3x plus 15 divided by x plus 4, x plus 5. We're keeping our addition sign. And then the right side becomes 6x plus 24 divided by x plus 4, x plus 5. And then again, we're adding across. So when we add across, we get 9x plus 39. So when we do that, we get 9x plus 39, and our denominator stays the same. So example 2 is going to be a little bit spicier. You definitely want to factor because it already looks large and you don't want to do any extra work. So let's go ahead and factor that. So to start, we have 3x all divided by x minus x plus 5 times x minus 2 minus 2x all divided by x plus 3, x minus 2. And so now that we have a better look at our denominators, we're really just trying to find out what they don't have in common. So if you look at the denominators, they both have an x minus 2. Where this left side is lacking is that it doesn't have an x plus 3. So that's what we need to multiply by. So notice again we are changing the color so you see what we're doing differently. So we're multiplying by x plus 3. And then we're keeping our subtraction sign. And on the right side, it's lacking, if you look at the denominators, it doesn't have an x plus 5. So that's exactly what we're going to add to this. So we have x plus 5 that we're multiplying across. And notice, when we're working with the denominators, we're not actually changing or multiplying them out. So we'll be left with, on the numerators, we have 3x squared plus 9x minus 2x squared plus 10x And your numerator now shouldn't change. It should stay, or sorry, your denominators should now be matching. So you will have on your denominator x plus 5, x minus 2, x plus 3. Notice, no need to multiply that out. It's just a waste of your time for now. So when we do that, and now that they're finally matching, we are going to subtract across. So we have to be very specific, so please listen to the way I word it. It's 3x squared minus 2x squared, so that means you have x squared. You have 9x minus 10x, so that should be minus x. Because you're subtracting each piece from the other. And now the denominator, you should have the same exact denominator you had to begin with, which is the following. And the last thing we're going to cover today is simplifying complex rational expressions. So in this instance, we have the same four steps. We have multiply the denominators to make them common, simplify each fraction on the numerator and denominator, and then copy dot flip and then multiply across. So you'll notice for this one that we're trying to simplify first the numerator and then the denominator. So let's look at that. So we have 1 plus 1 divided by x. Notice that this has a fraction and it's 1 divided by x, the other one doesn't. So in order for us to make that work, we need to make the other one a fraction. So to make their denominators common, we have to multiply this 1 on the left with an x. So let's first make it a fraction on its own. And we can make anything a fraction by dividing by 1, and that's what we're going to do. And this one obviously is not in a fraction, so let's make it look like a fraction. So now we have to multiply by x to the bottom and to the top, so x and x. So this gives us x divided by x. And on the right side, we still have our 1 divided by x, but at least we can now add them up. And so that's what we'll do. When we add those up, you're left with x plus 1 all divided by x. So what we've just done here is we've only simplified the numerator. So here it is. I'm going to write it right next to it, and that's all we've done. We haven't even touched the bottom or the denominator, so we'll go ahead and do that now. And please, I know it might look complicated, but just look at this in pieces. First we simplify the top, the numerator, and now we're going to simplify the denominator. So that's 3, or to make it a fraction now, it's 3 divided by 1, minus 1 divided by x, we want the denominators to be the same, so we're going to go ahead and multiply the left equation, or the left expression, by x, so that's x times x. And then we're going to be left with 3x all divided by x minus 1 divided by x. And when we do the subtraction, that's equal to 3x minus 1 all divided by x. And now we have officially simplified the denominator. So now we're going to solve the actual problem. So I'm going to move this over so it's out of our way. And now in order for us to solve this fraction, we have to copy dot flip. So now we're on step 3, so we're going to rewrite the whole first equation, so copy. We're going to change that division to a dot or multiplication. And then we are going to flip that second equation. So x divided by 3x minus 1. Now, we can multiply across, but notice we can probably do some cross-canceling. So we have an x on this numerator and x on this denominator. So when we multiply across, we are now left with x plus 1 divided by 3x minus 1, and now you're done. This is your final answer. Example 2. We'll try and run through this one a little bit faster this time around. We have the numerator. Okay, so we have x, or x divided by 1, plus 1 divided by x. Again, denominators don't match, so we need to multiply both top and bottom by x for the equation on the left. We're left with 8x divided by x, plus 1 divided by x. And so when we add that, we get 8x plus 1 divided by x. And then for the denominator, we'll do that in red. So we have 4, or 4 divided by 1, minus 1 divided by x. So again, we need to multiply by x on the denominator and numerator. We get 4x divided by x minus 1 divided by x. And so your denominator is going to officially look like 4x minus 1 divided by x. And if you'll notice, a lot of these look exactly the same in the way that we're doing it. And now that we have our numerator and denominator simplified, we are going to copy, like I literally just did. We're going to change the division to a dot for multiplication. And we are going to flip the bottom. So x divided by 4x minus 1. Cross cancel if you can. So you'll notice we have an x on the numerator, x on the denominator, so cancel those out. Your final answer should read 8x plus 1 divided by 4x minus 1. And just to make sure I make this clear, just because the 8 and the 4 have a common factor, you cannot cancel out the 8 and the 4 because they are connected to the plus 1 and the minus 1. So that's all for now. Make sure you write down any questions you might have, and we'll talk about it in class.